Okay, what are people saying about the Chinese mini lathe? You know, you hear people on YouTube, you know, with bigger machines, and probably have never even seen one of these machines in person. You know, making judgments on it. I dare them. Who's that? Greta? Greta somebody? I dare you. Tangent. Yeah, the most common thing I hear is, yeah, well, it's really good, you know, for plastics or aluminum. You know, you can do a lot with that little thing. But you know, I'm here to disprove that. I have a variety of materials here. I'm going to demonstrate as best I can with a file the hardness of the materials. I have some stuff that's pretty hard. I have some tempted. We have a bunch of center punches that are just an oddball set, and it's you know, that's definitely hardened material. We might try to cut that. And I have some cast iron, I believe, but I have to get the forge all out to do that. So we're going to be doing all the testing or demonstrating with the TCMT insert. Let me clean it up a little bit and get you. I can't tell you anything other than TCMT. I know I'm learning that that's pretty vague. It could be there's probably 100 TCMTs. But that's the profile of it, what it looks like. And this is the tool that I just rediscovered, and also rediscovered that it is does an excellent job on aluminum. And that's all these mini lathes are good for, is aluminum. So let me show you what materials I have and what we'll be doing with them. Well, obviously we're going to be turning them. I have a piece of brass. Is that brass or bronze? I actually think that's brass. A piece of copper, very gummy, very tricky. This here, I have no idea. You know, I can put a mark on it. I would say it. I would say it files. Let me do a comparison so I can. Okay, not super hard, I guess. I think this is hot rolled. And that's pretty hard. That's hard. That's the hardest thing I've come across yet. Don't know what this is, where it came from. File just kind of glides across that. It's marking it, but not very much. And here's a piece of my favorite 12L14. Yeah. And we all know that machine's like butter. And this is, someone's been using this as a drift. And once again, that's just sliding off there. We probably won't be able to cut that. So there are the candidates. Oh, and then a piece of plastic. Okay, here's our first cut, interrupted cut of plastic. I don't have anything that's, you can see that, yeah, I'm sure you can see it. I don't have anything that's perfectly round. And we're gonna kind of find the zero here. Okay, we're gonna call that 0. And we're gonna start with 20 thousandths an inch, 25. Okay, we had 450 RPMs, and I'm gonna feed this by hand. Let me back that off. Okay. It seems to do a very nice job cutting plastic. Let's take a deeper cut. Let's try 100 thousandths. Okay, there's a little 2 thousandths over 100 thousandths. Okay, there we go with plastic. I don't know what kind of plastic it is. It's just some kind of plastic. I hear people say Delron. I have no idea what it is, but I'm going to call it that too. Yeah, that machine's pretty easy. It's a great machine if you're just going to be machining plastic. Nice manageable chips. Usually when you do the plastic, you don't get chips. Of course, you usually don't do 100 thousandths cut either. Okay, so let's take this brass or bronze. Let's just call it brass. I think bronze would just be a little harder maybe. And harder doesn't necessarily mean harder to machine either. Okay, same insert. I'm going to take this up to 550 RPMs. I'm going to find our center. Or find our 0. Okay, we'll call that 0. And we will do 25 thousandths once more. And no surprise. Now here, I want to do something a little different. I want to take away everything but a number. So I have basically 380 thousandths. I want to leave 50 thousandths. So we're going to subtract 50 thousandths from this number. Let's just call that 400. So let's say 350 thousandths. No, half of that. I'm sorry, 150, 350 thousandths, 150, 175. Is that right? Well, okay, there's 175 thousandths with brass. That's 625 RPMs. Okay, so you don't like that. Well, I'm determined to do that. Okay. Just didn't have enough hold on the material. Okay, let me see what this little nib is here. It's 63 thousandths. $63 thousandths. There's millimeters. Okay, let's check that nub again. Okay, 64 thousandths. 50. 500. So I'm going to take 64 away from 500. It'll be 450, 440, 440 thousandths. Let's just take, so if we make it up there, it'll be 440 thousandths. Okay, we're being ridiculous, I guess. Okay, basically with brass, you can just test the limits. Okay, and here's some brass. Let's find the 0 on this. Call that 0. I'm going to do 25 thousandths. There's 25 thousandths. Let's do 100 thousandths. There's our 100 thousandths. I don't think that's going to leave much. Okay, we have our brass, and so let's we're going to make that our 0. Here's 70 thousandths. Brass is obviously going to machine very well. So there's no nothing to prove there with brass. So let's pull that out of there. I don't think I have a piece of aluminum out here. Let me find a piece of aluminum. Okay, we killed that for the compressor to go off, but okay, I think despite the we never got to this piece. Despite the little setback, maybe setbacks we had, I think I proved my point that you can definitely do more than plastic and aluminum. Well, I think this is the toughest metal yet. Maybe it's case hardened. Okay, once again, I want to make that safe to touch. Oh dear. Okay, that turned into a little bit more than just a, actually no, it was a perfect demonstration that the mini lathe is capable of much more than most people assume. Craig Tate came over and got me all wired up in 3-phase, and he had never been in front of one of these in person, and he commented, he says, I can't believe how small that really is. And he says on the video it just looks like, you know, it's just a lathe, but it's small. Wow, did you see that? You guys might have got a ride out of that. I'm basically gonna stick this on my armpit. Okay, and I can reach the end of the lathe. So that entire lathe is the length of my arm. It's funny because I go to like a real machine shop, and their tool holders are as big as my headstock. Man, did I just what do they call it? Did I just go off on a tangent? Apparently I do that from time to time. I'm satisfied. All I wanted to do was demonstrate that this thing can cut, you know, just about anything I can put in front of it. I don't have any titanium, or I don't have any stainless, but you know, mild steel, 12L20, copper. We didn't do copper. Well, I'll show you we can do copper. Here, I got copper. I got copper chips. You know, this is you know, 75 thousandths or so. This is copper. I love this because it's dull there and it's shiny there. It's almost like a magic. Did I go off on another tangent? I could have just put some copper in the lathe and machined it. You know, so here's some other examples of copper. I have my whatever it is. It's tapered inside and outside. I have my knocker. I have my eccentric on ball bearings, which doesn't do anything at all. Are we even on camera? Yeah. So, you know, it'll do copper, and copper's tough. Copper ain't easy. I parted copper tonight in a previous video, and that's, you know, 75, 100 RPMs. It's, you treat it differently than other materials. I'm off on that frickin' tangent again, aren't I? Thanks for watching. Thanks for subscribing. Tell a buddy, bring a friend. And until next time.